Good morning, class. We are looking at Chapter 11, Sequences and Series. There's section 11.2, Arithmetic Sequences and Series. We covered sequence and series, now arithmetic sequence and series, and the objectives are: find the common difference from an arithmetic sequence, write terms of an arithmetic sequence, use a recursive formula for an arithmetic sequence, use an explicit formula for an arithmetic sequence. What did we cover? Recall, a sequence is a list of numbers written in a specific order, a sub 1, a sub 2, all the way to a sub n, the first, second, all the way to nth term of the sequence. A sub n is the general term, and n is the set of positive numbers, 1, 2, 3, also known as whole numbers or counting numbers. Recursive sequence, also known as a difference equation. The form is a sub n plus 1 is f of a sub n. The next term depends on knowing the previous one or previous ones. Example, Fibonacci sequence. F1, the first term is 1, second one is 1, and then we have f sub n equals f sub n minus 1 plus f sub n minus 2, meaning add the previous two when n is larger than or equal to 1. So we have 1 and 1. Then we add these two, we get 2, add these two, we get 3, so on and so forth. So the next one, as an example, we need to add these two, and we get 34. That's Fibonacci sequence. Arithmetic sequence, A1, A1 plus D, A1 plus 2D, and so forth. The recursive format would be A sub n plus 1 or A sub n plus D. D is the difference, it's the common, it's the constant difference or distance is called. Explicitly by A sub n equals A sub 1 plus n minus 1 times D. If you're dealing with the geometric sequence, A1, A1R all the way to I1R to the power n minus 1. And the recursive format would be A sub n plus 1 is R times A sub n. In other words, if you want a term, pick a previous one multiplied by R, known as a common ratio. Explicitly, A sub n equals A sub 1, R to the power of n minus 1. N factorial is n times n minus 1 times n minus 2 all the way to 1. That's the definition of it, factorial. Series and summation notation. S sub n, the sum of a sub 1 plus a sub 2 all the way to a sub n is called S sub n of the first n terms of the sequence, a sub 1, a sub 2, and a sub 3. When we add the first n terms, we call them S sub n. Sigma is the Greek letter and indicates the sum. The sigma notation, summation of I from 1 to n of a sub I, means add the terms a sub I beginning with the first term and ending with the nth term. I is called the index of summation. A finite series S sub n, it ends at n, summation of I from 1 to n a sub I. But an infinite series, S sub infinity, it just keeps on going. So the summation of I from 1 to infinity, a sub I. Summation properties, if a sub 1, a sub 2, and a sub 3, and a sub n, as well as b sub 1, b sub 2, b sub n are two sequences, and c is the number, is a constant, then for every positive integer n, you have the following. Summation of I going from 1 to n, c is nc. If it's c, we can take it out times summation of a sub I. If you have sum and difference, you can cut it into two pieces. Summation of I is n times n plus 1 over 2. Summation of I squared is n times n plus 1 times 2n plus 1. Summation of I cubed is n squared times n plus 1 squared over 4. So that's what we have so far. And now let's get to the arithmetic sequence and series, the new stuff. 11.2 arithmetic sequence and series. An arithmetic sequence, each term after the first one is found by adding a fixed number called the common difference to the previous term is an arithmetic sequence or arithmetic progression. A sub 1, A sub 1 plus D, A sub 1 plus 2D, and so on. The difference D between consecutive terms is constant, and the sequence can be defined by recursive format, A sub n plus 1 is A sub n plus D, or explicitly by A sub n equals A sub 1 plus n minus 1 times D. Example, 1, 5, 9, 13. As you can see, we are adding a common difference of 4, 1 plus 4, 5 plus 4, 9 plus 4, 13 plus 4 is 17, so on and so forth. The nth term is given by A sub n equals A sub 1 plus n minus 1 times t. The sum of the first n terms is given by A sub n equals n over 2, A sub 1 plus A sub n, or n over 2. If you replace A sub n with this one, then it becomes 2A sub 1 plus n minus 1 times d. So here's the synopsis of that. A sub n is A sub 1 plus n minus 1 times d. A sub n plus 1 is A sub n plus d. S sub n is n over 2 times A sub 1 plus A sub n, or S sub n equals n over 2, 2 times A sub n plus n minus 1 times d. All right, here's the first example. Find the first 5 terms of the arithmetic sequence. The first term is 7, and the common difference is negative 3. So according to this, A sub 1 is 7, D is negative 3. So if the first one is 7, the second one would be 7 and add this number. With negative 3, you get 4. And then add negative 3, you get 1, so on and so forth. So we add negative 3, we get 4. We add negative 3 again, we get 1. We add negative 3 again, we get negative 2. And we want 5 terms, so 1 more. And we get negative 5. Part B. A sub 1 equals negative 12 and D equals 5. It's just given. So that's given. You don't really have to. This wasn't written symbolically. This was. So what is the next? If the first term is negative 12, the next one would be negative 12 plus 5 minus 7. The next one, we add 5 again. We get negative 2. The next one, we add 5 again, and we get 3. So it's pretty straightforward, everybody. And we add 5 again. we get 8. So it's pretty straightforward, everybody. Example 2, show that the sequence is arithmetic. List the first term and the common difference. That's how you prove it. So we want to find a sub 1, and the obviously a sub 1 is 4. What number do you add to get to 2? You subtract 4 from 2. So 2 minus 4. Okay, so again, the way you find the D, you say 2 minus 4. So 2 minus 4. Or 0 minus 2. Or minus 2 minus 0. Of course, you really should do a few just to make sure that these not changing. That's the proof that makes it an arithmetic sequence. What about this? S sub n is 4n minus 1. So we need to find a couple of terms and the difference. So the first term, if I want a sub 1, I just replace the n with 1. And I get 4 times minus 1, which is 3. There are a couple of different ways to look at that. I go with a sub 2. Let me do different color. A sub 2 would be 4 times 2 minus 8 minus 1 is 7. I do a sub 3. 4 times 3, 12 minus 1 is 11. So I have that, and that shows me D must be 4, right? We are adding 4. And that works, and we are fine, everybody. We can also look at S sub n minus S sub n minus 1, a general form of that. To see what we end up with. We can do that. So let me erase my work so we have enough room. S sub n is 4n minus 1 minus S sub n minus 1, replace n with n minus 1 and observe. So this is 4n minus 4 minus 1. So we have 4n minus 1 This is minus 5. So we apply the negative, becomes minus 4n, and minus 5 is plus 5. And these two cancel each other. Negative 1 and 5, they add up to 4. T sub n is 2 minus 3. Again, we're going to write a few of them. So starting with the first term, a sub 1, 2 minus 3 times 1. So 2 minus 3 is negative 1. Let's write the second one. So let me use a different color. A sub 2 would be 2 times minus 3 times. Now n is 2 now. So 2 minus 6 minus 4. Write one more. 2 minus 3 times 3. 3 times 3 is 9. 2 minus 9 is minus 7. So here's the sequence. So in other words, what is it that we are adding here? We are adding minus 3. What are we adding here? Negative 3, and so on. So the next one should be minus 10, and that proves that D must be negative 3. Okay. So the common difference is negative 3. Now, if you want to generalize that, we can go with this methodology again. So that means replace the n with n, so it's itself 2 minus 3n, and then replace it with n minus 1. And let me erase my work so I can show you the rest of it here. So I'm going to erase this. So inside the parentheses, we have a 2 minus 3n minus 3 times minus 1 is plus 3. And so 2 and 3 is 5. So we have 2 minus 3n. Now we're going to apply the negative. 2 and 3 is 5, so minus 5. And then minus and minus 3n is plus 3n. These two cancel each other. The two add up to negative 3. So it's very straightforward, everybody. I hope everybody's following that. So to prove something is an arithmetic sequence, you have to check and come up with the first term and the D. And then when you claim that's the case, the next one should work also. If I work the next one here and it's 3, I get 14 and 17 and so forth. Over here, keep on subtracting 3, minus 10, minus 13, and so forth. So you check it that way. Find the sum of the first 60 positive integers. So what are we dealing with? We are dealing with 1, 2, 3 to 60. The first term is 1. The last term is 60. And we want this sum that means we want S sub 60. So A1 is 1, D is 1, S sub 60 is of interest to us. So it's, in other words, you are dissecting the problem to see what is it that you want in this case. So you can use either this formula or this formula. If the first and the last term, The first term is 1, the last term is 6. It's given, it's easier to use that one. Otherwise, if you don't have the last term, just use the first term as follows. So we are going to go with that formula, and we are going to replace the n with 60, a sub 1 with 1, a sub n with 60. And so obviously this is 30, right? 30 times 61, 1830, 1830. Find a sub 13 and a sub n for this arithmetic sequence. So first, let's see what's given. Obviously, this is a sub 1, and their difference would be t. So a sub 1 is -3. So 1 minus minus 3 is 4, 5 minus 1 is 4, 9 minus 5 is 4. So a sub 1 is -3, and the d is 4. When you say it's 4, you really want to check. So add 4 here, add 4 here, add 4 here. So not just 1, just write these two. Just continue checking. If you're claiming the d is 4, oh, the first term is, just look at it. But what is the d? You check and recheck. So we want a sub 13. We want a sub 13. We're going to use n equals 13. In this formula, we use n equals 30. A sub 1, -3. D is a 4. -48 and -3 result in 45. So that's pretty straightforward, everybody. What about a sub n? We use again the same formula and replace what we have, and we are going to simplify accordingly. So we are going to distribute the 4. So we get -3 plus 4n minus 4. We can add these two, and a sub n is 4n minus 7. Just for the sake of argument to see how that works, if I want to calculate a sub 13 using this means 4 times 30 minus 7, 52 minus 7. You're supposed to get 45. And that's, by the way, one way to check this. Find the formula for the general term a sub n of this sequence. Well, what type of a sequence do we have? Here's the first term, and I need to add 3 to get to the next one. Again, 3. That means it's an arithmetic sequence with the difference of 3. A sub 1 is 5. D is 3. So we first notice the type of a sequence that is given to us. And to find the general formula, since we don't have the nth term, okay, for a sub n, use this one, we want a sub n. If we want s sub n, we could use also the last. So a sub 1 plus n minus 1 times d, just plug in a sub 1, which is 5, and d, which is 3, distribute, this becomes 3n minus 3, and 5 and negative 3 add up to 2, so 3n plus 2. The sum of the first 17 terms of an arithmetic sequence, it is telling us it's 187. If A17, the 17th term, is given as negative 13, find A1 and D, because in order for you to write out an arithmetic sequence, you really should have the first term and then D you can keep on writing. That's why they're asking. So the very first thing, what is this? The sum of the first 17 terms means S sub 17 is given as 187, and this is, of course, A70. So with that being the case, we can use S sub n, this formula or this formula, because this one is given, we're going to use this one, and we're going to say S sub n equals n over 2 times a sub 1 plus a sub n. And for n, we are going to use 17. Therefore, S sub 17 is n over 2, 17 halves, times a1 plus a17. And so if I plug in S17, which is 187, and A17, which is negative 13, pretty much we have the answer. The fastest way is to multiply both sides by 2 over 17. So if I multiply by 2 over 17, everybody, is to cancel each other. So the right side is A1 minus 13. This is 11. So we get 22. We move negative becomes positive on the other side. A1 becomes 35. So that's pretty straightforward. Now we want to find the value of D. So what do? Very simple. We have A sub 1 missing. We have A sub 17 given. We can find the D. So A sub 17. So we are using this one. Equals A sub 1 plus 17 minus 1 times D. A sub 17 is negative 13. A sub 1 is 35. 17 minus 1 is 16. Move the 35. You get minus 48. Divide both sides by 16. D becomes negative 3. So A1 is 35. D is negative 3. And we are done. Suppose that an arithmetic sequence has A sub 8 equals negative 16, A sub 16 equals negative 4D. Find A sub 1 and D and evaluate S12. Again, if you're dealing with the arithmetic sequence, an arithmetic sequence is known when we have these two pieces, everybody. What is the first term? What is the difference? That's all. And this, in essence, is giving us a system of equations. Two equations, two unknowns. What are the two equations? Well, A sub 8, we are going to go with this formula, everybody. We're going to write A sub 8 as A sub 1 plus n minus 1, 8 minus 1 times D. And A sub 16, we are going to do A sub 1 plus 16 minus 1 times D. So this is A sub 8 according to that formula. And this is A sub 16. We are going to replace A sub 8 with negative 16, A sub 16 with negative 40. So we are looking at the system as it was explained. So think about it. We're going to solve the system, and we are looking at this. So one easy way is to get rid of a sub 1. So to get rid of a sub 1, multiply one of them by a negative 1. So solve by the system, multiply by negative 1. It really doesn't matter which one. So we keep the first one intact because this has negative. Let's do this. So we get minus a1, minus 15d, positive 4. Notice these two cancel each other. These two add up to negative 8d. These two add up to positive 24. Divide by negative 8. D is negative 3. So that's pretty straightforward, everybody. So I want to make sure that everybody's following that, all these steps that were done very clearly. Now we use one of the equations. For example, let's use this one. A sub 1 plus 7 times d equals negative 16. So a sub 1 plus 7 times negative 3 is negative 16. We have negative 21. We move it, becomes positive 21, and a sub 1 becomes 5. So we found this part. What is left is S sub 12. And to find S sub 12, we are going to use this formula or this formula. Because we don't have A sub 12, we're going to use this formula. So let's plug in whatever we have. So n is 12, 2 times a1 is 5, n is 12, minus 1, d is negative 3, and so 12 divided by 2 is 6, 2 times 5 is 10, this is 11 times negative 3 is negative 33, and so we have minus 23 times 6, negative 138 is the final answer for S sub 12. So pretty straightforward. So a quick recap. It's important to understand, according to what's given, A sub 16 and A sub 16 and A sub 8, we have two equations, two unknowns. Using a system of equations, we will get to A sub 1 and D, and the rest becomes a piece of cake. You're going to move on, everybody. Find the summation of 1 to 10 for I plus 8. Well, what it means, everybody, is that we have to plug in I equals 1, find the answer, plus 2, plus 3, and so forth. That's the concept, okay? And you can do that. But here's the easy way that we notice. The sum covers the terms of an arithmetic sequence. How do we know that? If you look at the first term, okay, replace the I with 1, you get 4 times 1 plus 8. You want to go all the way to 10. So the 10th term, a sub 10, is 4 times 10. And notice that if you put 2, you get 12. Put 3 times 4, 12, and 8 is 20. So the sequence is an arithmetic sequence. Is positive 4. You see that? So a sub 10 equals 4 times 10 plus 8 is 48. And since this is the summation, in essence, we want S sub n, or more specifically, we want S sub 10. So this one, because it's an arithmetic sequence, we use the easy way out. Again, please understand, if you don't have the arithmetic sequence, you have to do 4 times 1 plus 8, one of them. In other words, you would do this, 4 times 1 plus 8. That's the meaning of a summation. 4 times 2 plus 8 plus all the way 4 times 10 plus 8. That's the meaning of a summation. Because we recognize this is an arithmetic sequence, we don't have to go that route, but rather we are going to go with the easy way out and use this formula. So let's plug in. 10 halves, this is 2, 5, 10 halves, it's 5, 12 and 48 is 60. The product is 300. Find if Find the formula for the nth term of the sequence graphed below. Solution: the equation of the dashed line shown below is y equals minus 0.5x plus 4. Why is that? How do we know that? Let's look at the proof. Well, just pick up a couple of pairs, easy ones. For example, this one has coordinates 2, 3. This one has coordinates 4, 2. So let me just use a red mark here. Let's see. This one and this one, okay? You have 2 points. Calculate the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 2 minus 3, 4 minus 2, and we get negative 1/2. I'm assuming nobody has any problem with this. y minus y1 equals m times x minus x of 1. Pick one of those pairs, for example, 2 comma 3. So y minus 3 equals negative 1 half x minus 2. This gives us y minus 3 is negative 1 half x plus 1. Move this, and we get this one. And I highly recommend, after you get that, check with this point, the other points, to make sure this is right. Okay, I'm going to leave it for you to check that. Therefore, the sequence is given by a sub n equals that, negative 1 half x plus 4 for the line, but this is not a line, this is a bunch of dots. So for the dots, it's given negative 1 half n plus 4. Where n is 1, 2, 3, 4, 5, 6. And here's how you check it. Let me erase my work. If you plug in 1, this becomes negative 0.5 and 4. Positive 1 gives you 3.5. 1 gives you 3.5. Plug in 2, you get negative 1 and 4 is 3. 2 gives you 3. The next one, 3. If I put 3 here, negative 1.5 and 4 is 2.5. And you can check the rest of them. You must check. I can't emphasize the importance of checking. Okay? You must check. Example, a mosaic tile floor is designed in the shape of a trapezoid, 30 feet wide at the base, 15 feet wide at the top. The tiles 12 inches by 12 inches, 1 foot by 1 foot, are to be placed so that each successive row contains one less tile than the row below. So this one has one more than this one, or you can say this one is one less than this one. That's the way it goes. How many tiles will be required? So let's see what we have. 15 feet, 30 feet, so 15 at top, 30 at the bottom. We have 15 tiles up here because each tile is 12 inch by 12 inch, or 1 foot by 1 foot. That's why. Okay. That's the meaning of it. So how many down there? 30 tiles, which means now that we have 15, the next one must have 16, 17, 18, 19, all the way to 30, because each successive row contains one less tile than the row below. So the row below has one more, which means we can treat this as an arithmetic sequence. Okay. S, the sum is 15 plus 16 all the way to 30. Why the next one is 16? Because it says so here. Take a look. Each successive row contains one less than the row below. So if this has 15, this must have one more. 16, 17, and so forth. That's the meaning of it. So arithmetic sequence, A sub 1 is 15, D equals 1. Okay. So If a sub 1 is 15, we have the last one. A sub what? 30 minus 15 plus 1 makes it 16 because that is included. You can count if you want. So n is 16. There are 16 rows. So a sub n, which is a sub 16, is 30, and we want the s. From 15 to 30, because it includes 15. You can count that if you want. It's like from any number to any number. Okay. If you count them 30 minus 15, that gives you 16 rows. All right, so we use this formula because we have the first and the last term. A sub 1 is 15, a sub n is 30, and n is 16. So this is 8 times 45. The answer is 360 times. So the answer is 360 times. So it's pretty straightforward, everybody. It follows arithmetic sequence.